Hello, Physics 1. Mr. Janowski again with another question from the Chapter 10 study guide. So this is question number 4. We've got Charlie sitting on the edge of a merry-go-round, 1.35 meters from the center. The ride makes one revolution every 4.10 seconds. So we've got a few things to figure out. So let's go with a big long step, wrong tool. So what have we got? Step, part A. How far does Charlie travel during one complete rotation? So how far? All right, well, that's a distance, but in this case, because he's going around in a circle, it's really the arc length. So I'm going to change it to S, and that is equal to question mark, and how far? Well, it's going to be in meters. B, what is his tangential velocity? So V tangential is equal to question mark, and what are the units of this? Well, it is a velocity, a good old-fashioned velocity, so this will be meters per second. So make sure you know the difference between tangential velocity and angular velocity. Part C, what is his centripetal acceleration? So make sure you know the difference between centripetal acceleration, which is A sub c, which comes in units of meters per second squared, and angular acceleration, which is alpha, and that comes in radians per second squared. Part D. So Charlie has that mass. How much centripetal force? So we're looking for F sub c, and that will be in units of, what are the units of force? Newtons, of course. And E, what is the fastest angular velocity? So this time we're looking for angular velocity. Do you remember the symbol for that one? Yep, it's omega. And that is equal to question mark, and that will come in units of radians per second. So again, make sure you know the difference between angular velocity and tangential velocity, and angular acceleration and centripetal acceleration. So all different ideas. So let's get going with part A. So how far does Charlie travel during one complete rotation? And we're looking for the arc length. So, we have this formula. S is equal to r theta. So r is equal to 1.35 meters. That's how far Charlie's sitting from the edge. And in order to use this formula, theta needs to be in units of radians. So we know he goes one revolution. So how many radians is one revolution? Well, you can do the whole thing with the fuel goalpost, or you can just remember that one revolution is 2 pi radians. So ask calculator. Multiply 1.35 times 2 times pi. Don't forget to multiply it by pi. Pi is a number. And your calculator will tell you 8.48. And the units, although it might look like we should have units of meters, radians, this is one of those cases where radians just goes away. Whoop. So we have that, 8.48 meters. So another way of thinking of this is if you think about what Charlie's doing, so if we actually did a step 1 for this, Charlie is going around in a circle in the picture that I don't have in this, but it is on the worksheet. That's a decent circle. So Charlie's going to start here. He's going to go around this way. Once he goes all the way around, he has gone one circumference of the circle. So what's the formula for the circumference of a circle? C is equal to 2 pi radius. So convince yourself that 2 pi radius is exactly what we've done here. So this was radius. This was 2 pi. So yeah, same dealie. Just a different way of thinking of it. So on to part B. What is his tangential velocity? So the easiest way of thinking of this is just what's your formula for regular old velocity? Kind of the definition of velocity is distance over time. So what distance does Charlie go every time he goes around? Well, it's our answer to part A. he does, one circumference of this circle, so 4.8 meters. And how long does it take him to go all the way around? It takes him 4.10 seconds. So plug that into the calculator, and you will get 2.07, and look at your units, meters divided by seconds. So put a box around it. Yeah, we solved for the right thing. We gave it the right units, so that's good. Forgot to give this one a check. There, now it gets a check. So that's that one. Let's see, let's find a nice purple. All right. Part C. What is his centripetal acceleration? So we're looking for A sub C. Centripetal acceleration, have we got a formula for that in terms of things that we know? Yes, we do. We know tangential velocity, and we know the radius. So here's a formula for centripetal acceleration. So you plug in the numbers, 2.07 meters per second, which gets squared, and this gets divided by our radius. Our radius is 1.35 meters. So put that in the calculator, and you will get 3.17, and let's think of the units. Meters per second, if that gets squared, that would give you meters squared per second squared, and then the whole thing is getting divided by meters. So one of those meters cancels, and you end up with meters per second squared, which is the right units for what we're looking for. So we happy. On to, let me get a little bit more space here. Part D. What color haven't we used? We'll do kind of a teal. Can I make it a dark teal? That'll do. That's kind of a weird color. All right, we'll go with it. Yeah, part D. We're looking for centripetal force. So how can we figure out the centripetal force? Well, what's the most important thing you've learned in physics all year? F equals ma. So the formula for centripetal force is going to be mass times centripetal acceleration, which is the thing we just figured out. So we're just quickly plugging in the numbers. Charlie has a mass of 46.5 kilograms times his centripetal acceleration, which is this number. So this is a common thing, hopefully you've noticed kind of throughout the year. If you get one of these multi-step problems, you'll solve for something in part A, and you might need that thing to get part B. And then you might need one or both of those things to get part C, et cetera, et cetera. So yeah, the parts kind of lead into each other. Anyhow, if you take these numbers and plug them in, 46.5 times 3.17, your calculator friend will tell you 147, and the units, kilograms, meters per second squared, better known as newtons. Those are your units for force. So you have that. And last one, I'll go with one of these. That might look a little like what we had for D. Oh, all right. Oh, well, we'll be fine. Okay. So for the last one, what is the fastest angular velocity? So parts A through D are all kind of the same situation. Part E is a little different. Now Charlie's going to go faster, and we're trying to figure out what's the fastest he'll be able to go around without falling off if friction can provide at most 175 newtons. So go back to, well, we'll start here. F sub c is equal to m a sub c. So we've got two different expressions for, let me get a little bit more room here. We have two different expressions for centripetal acceleration. One of them has tangential velocity, and the other one has angular velocity. So, I mean, in this case, we're trying to solve for the angular velocity. Remember, if we go back to step, this is the thing we're looking for. So let's pick the one that has that. So F sub c is equal to m and r omega squared. So we know the force we're going to use. We know the mass. We know the radius. We want the omega. So you've got to do the little bit of algebra that gets you omega by itself, which is, let's divide both sides. I'll take it up to here. Let's divide both sides by mass and radius. So that'll give us F sub c over mass and radius is equal to omega squared. So then to solve this the rest of the way, we're going to want to take the square root of both sides. And if you do that, and if you switch left and right to make it a little bit easier to see, you're going to get, big square root, centripetal force. Remember, the maximum centripetal force that friction can provide in part E is 175 newtons. So it's, in this case, it's not your answer for part D. And we're dividing by the mass, which is 46. Make that a little bit nicer. 46.5 kilograms, and the radius is 1.35 meters. So let me make it clear exactly what's going on here. All right. So when you do this, make sure you get the order of operations correct. 175 divided by 46.5 and then divided by 1.35 meters. If you put this in the calculator wrong, it's going to be very easy to end up multiplying by 1.35 meters. So a couple ways to do that. I would do it a certain way. I would hit 175 divided by 46.5 and then divide by, again, that button, 1.35. The other way you could do this is do another set of parentheses. That would work. And then whatever you get for this part in the middle, don't forget to take the square root at the end. So raise it to the 1/2 power is how I would do it in the calculator. And yada, yada, yada. If you do all that, you will get 1.67. And what are the units of angular velocity? Radians per second. So put a box around it. We solved for the right thing. We gave it the right units. So we're happy. So hopefully you guys found that helpful.